Hello, welcome to Microsoft Build 2017. My name is Brian Turlson. I'm a program manager working on Chakra, and I'm here to talk to you about ChakraCore. So for those of you who aren't aware, ChakraCore is an open source JavaScript engine developed entirely on GitHub. It's cross-platform. In fact, I'm excited to announce that with the completion of our high-performance JIT and GC work, you can run ChakraCore on Linux just as well as you can on Windows. It's fully capable cross-platform JavaScript engine. ChakraCore is also standards compliant. In fact, we have support for the latest ES 2016 JavaScript standard, as well as the 2017 version, which has yet to be ratified. So you can check out this latest standards compliant work in the Creators Update of Microsoft Edge. It's also high performance. We care so much about performance and making your code run as fast as possible. And all of this goodness you can actually bring into your own applications by hosting ChakraCore to do a variety of things like, say, program game logic in JavaScript. So I'm going to talk about each of these things in more detail as we go on. So first, GitHub. ChakraCore is developed entirely on GitHub. A little bit over a year ago, we open sourced, and since then it's just been a ton of fun working with the community out there on GitHub, and really a privilege. So I definitely encourage anyone to go out to GitHub and check out our site. So one of the things you can do is keep on top of updates. All of the stuff that I'm going to talk about today, you could have discovered it early if you were watching on GitHub. So all of our performance work, all of our language work, all of it happens on GitHub, so you can definitely watch it there. And occasionally we'll create releases, so you can go and download the latest release, the source code, and in some cases also binaries. Filing bugs is also great. We definitely encourage you to, if you discover something that seems wrong with JavaScript, to go and file a bug and let us know about it. And also, it's a great way to get involved. You can even contribute to the ChakraCore code base. We've gotten a few pull requests from the community so far, and we've actually labeled these pull requests, some pull requests that we think will acclimate new people to the code base. So they're labeled with my first PR. So if you want to get involved, I definitely encourage you to go out, check out that label, see if there's some work there that might interest you. So as I mentioned, ChakraCore has full support for ES 2016 and ES 2017. And you can also play with these in the latest Creators Update of Microsoft Edge. So I'm kind of a language guy. I would spend hours talking to you about all of these new things. But unfortunately, I have just a couple minutes. So I want to talk about two of these that I think are especially important. The first is array.prototype.includes. And it's kind of weird to get excited about this simple of an API, but index of is just really a pain to use in a lot of cases. So the first case that makes it hard is it returns a number rather than true or false. And most of the time, you really want to just have true or false so you can use it much more easily in, say, an if statement. So that's one of the ways that includes is really nice. The other is, if you've ever tried to use index of to find nan in an array, not a number, it doesn't work. You had a bad time if you tried to do that. Includes actually works for nan. So it's a nice, convenient API that is easier to use and also works for all values that you might encounter in an array. So super handy. The next feature is actually one of the features that I'm most excited about in JavaScript right now, and that is async functions. Async functions were actually a feature that Microsoft championed through the standards process. We had a lot of experience with async functions in C#. And we even did some early implementation work of async functions in TypeScript. And we found that async functions are really just a phenomenal way to program asynchronous code in JavaScript. So the basics of an async function are, it's a promise returning function. You just put this little async keyword before the function. And now this function is an async function, and it returns a promise when you call it instead of returning the value directly. And the other useful aspect is, inside of the async function, you can await any promise value. And what that does is suspends the function until the promise resolves later. And so what that lets you do is, for example, this add function, which takes two promises for numbers and adds their results together. So it really drastically changes the way you write asynchronous code. It's just way friendlier to use than callbacks, and even friendlier than just using promises directly. And another thing that I should really call out here is that await of a rejected promise throws an exception. So with async functions, you can handle promise rejection errors using your normal synchronous control flow try-catch skills. So async functions, I think, will drastically change the way you write JavaScript code and are really a phenomenal feature that you can try out in the latest versions of ChakraCore and Microsoft Edge Creators Update. So as I mentioned also at the beginning, we care a lot about performance. We think a lot about performance. We're always talking to users to see, like, what are you building? What is it that is important for you for performance? Is it startup? Is it raw calculation performance? Is it maybe graphics or games? Or what are your workloads? We're always trying to understand what kind of work it is you're doing. We also take a look at real-world code, like digging into the internet and seeing what kind of code exists there and what we can do to make that code run better and help people have better experiences with your JavaScript code. We also look at industry benchmarks and other sources of data to just try and get a holistic picture of what performance looks like. So we're always working on performance, and so as I mentioned, you should really go to GitHub. You can watch a lot of this stuff happen. But one of the optimizations that I think is really cool that I want to talk about is function body redeferral. So this is not a CPU optimization. This is a memory optimization. And what this does is it teaches the ChakraCore engine to detect when a function is likely not to be called again. And in that case, we can throw away a bunch of memory that we just don't need to keep around anymore. And it turns out this saves a bunch of memory on real-world sites. So this is not something that you need to do as a developer to take advantage of. This is just ChakraCore saving memory when we don't need to use memory. Another really exciting performance-oriented feature is shared array buffers and atomics. Shared array buffers are a new type of buffer that you can put data into and actually share it among different threads, effectively web workers on the web platform. And so if you've tried to write parallel algorithms today, you've run across a problem, which is that buffers can only be shared by transferring, so you can transfer control completely to another web worker, or you can copy, so you get another copy of the data. In neither case are you working on the same data, so there's a lot of overhead to shuttle data back and forth between the workers. Shared array buffers change this, so you can actually share the same memory, and then you use the atomics object, which gives you certain primitives to access this data in a way that doesn't expose JavaScript to like data races and that kind of thing. So actually real parallel algorithms can actually be implemented on the web platform now. So you can play with this feature, again, in the latest version of Microsoft Edge in the Creators Update. You have to turn on experimental JavaScript features. Another such experimental feature is called WebAssembly. So WebAssembly is a assembly language, effectively, and environment that will execute this assembly code in the browser. And that's really cool because WebAssembly is actually designed to be a target for C and C++ code. And eventually, it may grow to incorporate even more languages, like hopefully C#. So WebAssembly lets you compile your C and C++ code directly to the web platform. It runs at near native performance. And I can actually demo what that looks like in the latest Creators Update. So we've got on webassembly.org, we've got this demo here. It's this tanks demo. So we're just going to play this game a little bit. And I promise this is not an excuse for me just to rest my voice. So made with the Unity game engine. That's important. This is actually a C++ game engine compiled to run in WebAssembly. So we're getting near native performance. Probably can't tell on the video, but I mean, the frame rate is just, oh, it's beautiful. And I'm also really good at this game. I have to play until I win. Ooh, that was easy. So that's WebAssembly. Definitely encourage you to check out this demo. And this is something that I'm really excited about because being a language nerd, having more of those languages available on the web platform, I think will be really quite awesome. Okay, so I want to pivot a little bit away from the web platform right now and talk about Node ChakraCore and Nappy. So Node ChakraCore is just a variant of Node, but whereas stock Node comes with the V8 JavaScript engine, Node ChakraCore comes with the ChakraCore JavaScript engine. And so there's another related project called Nappy, which is a stable API for native module developers. And these are related concepts, so I'll explain that. So when you're using a native module, which chances are you are if you've npm installed anything, the experience is great until you have to upgrade Node to the next version. So because these native modules are compiled directly against a version of the JavaScript engine, if you upgrade Node, usually you also have to recompile all of your modules. So that's kind of a pain. Likewise, if you want to swap between Node V8 and Node ChakraCore, you have to rebuild again. You have to recompile. So there's a lot of overhead involved with upgrading Node or switching between Node versions or switching between Node flavors. So we've been working with Node folks, with IBM and Node Source and Nearform and Intel and a bunch of others, the Node community, on working on this stable API that native module developers can use to target. And it will enable you to actually upgrade Node without rebuilding. And you could even swap Node V8 for Node ChakraCore without rebuilding anything. All of your modules just work without any additional effort. So that's really exciting. And you might be wondering at this point, OK, so I can switch Node. I can use Node ChakraCore. I can switch it in without recompiling. Why would I want to do that? Well, one of the reasons why is we think we can really help improve the debugging experience that Node developers have on a day-to-day basis. So I have a quick demo of a feature that we've been working on for a while here called time travel debugging. All right, so I'm going to come over to this VM I've got in the cloud. And I'm going to start Node. So this is actually Node ChakraCore, and I'm passing -- record, which is just enabling this time travel debugging feature. All right, so we've got the server started. Now we're going to come over to Edge and load my awesome application. And it's beautiful, right? It's just a beautiful app. It's a file previewer, which is super handy. You can click on files and you can read them. But I notice a bug. If I click on helloworld.js, it just kind of sits there. And OK, eventually it fails, saying we couldn't find the file. Recall this timestamp, the 621Z. We're going to see that a few more times. All right, so we're going to look over in the console here. And here's the 621Z, the timestamp. We also logged it to the console. And there's some additional text that's basically the application saying, hey, I noticed there was a problem. And I've written a trace file. And the trace file lets TTD do some pretty awesome stuff. So we're going to come over to VS Code. And the first thing that I'm going to do is I'm going to run a task to download that trace file that we just took. So this is going to do its thing for a couple seconds. All right, now in the debugger, I'm going to come over to this replay launch configuration, and I'm going to run it. So now I'm in the debugger, and this feels a lot like normal debugging, like I'm debugging something locally, but it's actually not, and I'll prove it to you. So we'll continue, and now we've hit this debugger statement, which is in this error handling routine. So clearly we've hit some kind of error. And in fact, this is the error that we observed in production. So I've got all of my normal debugging capabilities here, my watches, call stacks, breakpoints, all of that stuff. So I can pop up the call stack here. And we see we called this resource error function. Here's the 621Z that we saw earlier. Or rather, the 621Z is right here in the red. So that's the actual error that we saw previously in production. So let's say I want to debug this load file info function. How do I actually do that? Usually, you would have to restart the application and poke at it with the breakpoint in the right place. But with time travel debugging, we don't have to do that. Notice that my debugging toolbar here has a couple interesting buttons. There's the step back button, and there's this reverse button. And so I can actually use, that's where the name time travel debugging comes from, I can actually go backwards in time in my program to uncover really difficult to find bugs. So here I've actually hit a breakpoint that was behind where I was in the program. So like I can prove this to you by showing you like file path is undefined, and now I can step forward and it pulls in the right file path, and you can go to this, I guess, file request time. This is the 619Z. This is this log entry here. So with TTD, I could just bounce around the program forward and backward and uncover really difficult to find bugs. And I can just record a trace from, say, production or a staging environment, and like the program itself can actually detect when there are problems and decide when to take a trace file. So it's just really convenient for debugging these kinds of issues. So that's time travel debugging, a feature that I'm really excited about. All right, so the last thing that I want to talk about is JSRT, or the JavaScript Runtime APIs. So I mentioned at the beginning that ChakraCore is fully embeddable. You can embed ChakraCore in any application to enable scriptability. So one of the examples is for games. Another is like what DocDB does for running, say, stored procedures. There's a lot of interesting things you can do when you add JavaScript scriptability to whatever your application is. So JSRT APIs are these really simple C APIs, and they're actually really easy to get started with because they are actually really simple. And they also have, for the most part, an analog in JavaScript. So if you're more familiar with JavaScript than you are other programming languages, this should still be useful to you. It should be pretty clear what most of these functions are doing. And so on top of these APIs, we have a bunch of features that are specifically targeted to hosting scenarios. So one of the things that you're going to want, especially if you're running user code, like a stored procedure type scenario, is resource throttling. So you can say, hey, this code gets X% of CPU and Y% of memory, something like that. So resource throttling is something that you can do with JSRT. Likewise, script serialization. So oftentimes when you're shipping an app that also includes JavaScript, the JavaScript doesn't change from run to run. And so we don't need to do all of this initial setup cost of parsing your JavaScript code and building all of these internal structures, when we can instead do that at build time and serialize that and then just take advantage of it. So with script serialization, you get faster startup and more code throughput because you just don't do all of this initial startup work but once at the beginning. And we also have this rental threading model, which makes it pretty easy to manage your resources and get the best performance that you can out of the JavaScript that you have in your application. So with that, thank you for watching. Definitely check out these links. ChakraCore is on GitHub. Look forward to seeing you there. And thanks for watching.